All right. We're going to add. What are we going to add? +1 to both sides. Make sure you're showing me both sides. And then what happens with the ones on the left side? They cancel each other out. And on the right side, we got -3 plus +1. No. Nope. -3 and -2. -3 plus 1, they're opposite signs, so you subtract. 3 minus 1 is 2. Keep the sign of the bigger number. It's 3. So it's a -2. Box in that answer. M equals -2. N plus 18 is equal to 35. N plus 18 is equal to 35. Okay. What operation are they using?
Addition.
Addition. The opposite of that would be?
Subtraction.
What are we subtracting? 18. Happens on both sides of the equal sign. These 18s cancel each other out. Leaves just N. Okay. N. That's a letter N, yeah. And then what's 35 minus 18? 17? Positive or negative? Positive 17. Okay. Let's make that a -2. X minus 6 equals -2. X minus 6 equals -2. All right, what operation are they using?
Subtraction.
Subtraction. What's the opposite of that?
Addition.
Addition. So what are we going to add? 6 to both sides. So whatever they're doing, we're doing the inverse of that. So +6. Okay. What happens to the 6's on the left? They cancel out. There's X by itself. +4 or -4? +4, because they're opposite signs. Subtract. 6 minus 2 is 4. Keep the sign of the bigger. That's 4. That's 4. Okay. Not too difficult. Do this one on your own. Don't say anything to anybody. Don't call her out the answer or anything like that. X plus 7 equals 5. See if you can do this on your paper yourself. Make sure you show the steps stuff. I know that's picky, but I'm a mathematician. I'm supposed to be picky. Well, which one? The opposite sign. Or negative. No. All right, that one. I'm just gonna do that right. What operation should we use?
Subtraction.
Subtraction. We're subtracting 7 from both sides. So when we subtract 7 from 5, that answer is going to be negative, right? Negative 2 should have been the correct answer there. Most of you had that. That's a good job. All right, so integers, that's the easiest ones. Okay, no fractions, no decimals in that. That makes it easier. All right, let's look at one that maybe has, let's do decimals next. That's the next easiest, right? So let's do decimals. Say we had x minus 2.4 equals 6.7. Nothing really different about this other than it's a decimal instead of an integer. And we got to do what with our decimals? When we add, we have to do what with them? Line them up if we're going to do it by hand. So they're subtracting, so we're going to use addition. So we're going to add 2.4 to both sides. And make sure I'm lining up my decimals there because that's the way you're supposed to do it. 2.4s cancel out. And want to start on the right-hand side. 7 plus 4 is 11. So carry 1. And then we're adding 6 and 2, 8, 9. Where does the decimal go? After the 1 or before the 1? Before, between the 9 and the 1. There's X. 9.1 out of that. How can I check to make sure that's right? Plug it into the problems. If I put 9.1 in here in the original problem, is 9.1 minus 2.4 6.7? Yes, it is. That's how you can check any answer. When you're dealing with equations, no matter if it's these easy ones like this or next semester when we get to some really tough ones, if it's an equation, you plug your answer into the original problem and see if it's right. So there shouldn't be a case if you can do the arithmetic. It shouldn't be a problem checking to see if you got the right answer or not. All right, let's look at this one. Maybe m plus 5.6 equals 8.2. M plus 5.6 equals 8.2. What should we do to solve this one? Subtract 5.6 from both sides? Yeah. Perfect. That's the right thing. So when I do that, the 5.6s do what? Yep, cancel each other out. There's m by itself. Now, can we take 2 minus 6? No, got to borrow 1. That's going to be 6. 7 minus 5 is that answer positive or negative? Positive. Positive 8.2 is bigger than 5.6. So when you subtract them, they get the same. Positive answer. 0.6. Again, notice I'm not doing any of this with a calculator because you don't have to have a calculator to do this. The more you make yourself do things without the calculator, the better you're going to be at math and better you're going to be at algebra. Even though this is just basic add subtracted numbers, we're going to get to where we're putting letters in everything. And there's going to be more than a bunch, in there. So being able to do things without a calculator is always a good thing. So try your best to only check yourself with the calculator. Right? You try it without the calculator first, and then you can check yourself with the calculator. So be careful of that. All right. Let's do this one. X minus 8.01 equals negative 5.81. What do we do to solve this one? We're going to add 8.01 to both sides. $8 and a penny. These cancel. There's x by itself. That's what we're trying to get. It's variable by itself the whole time. Now, they're opposite signs. So that means I want to subtract them and keep the sign of the bigger one. Not while I'm teaching. And so it does me better if I stack them up this way. 0, I got a R1. 2.20. Positive because the $8 and a penny was more than the negative $5.81. Y plus 6.5 equals negative 2.3. Y plus 6.5 equals negative 2.3. What we do to solve this one? Minus. Okay, so we're going to use subtraction. I'm going to subtract 6.5 from both sides. Cancels out the 6.5 on the left side. That gives me y. They're both negative. So when we get them together, what's the answer going to be? No. Negative. More negative. So we got a negative number and we're subtracting from it, so we're going to get more negative. It's kind of like I owe you $2.30 and then I borrowed $6.50 from you today. So that means I'm going to owe you how much? $8.80. So signs are the same here. We're adding those together and keeping it negative. So 3 plus 5 is 8, 2 plus 6 is 8. Both negative. The time that it changes to a positive is if you're multiplying or dividing. Okay, so keep that in mind. That's going to be a shouldn't do that in algebra. Can you wait 5 minutes? 5 minutes, okay? We'll be done in 5 minutes. All right. Let's do one on our own real quick. X plus 3.4 equals 2.7. You can do this one on your own. Yeah, get the solution here. Show that step, show you where doing to get there. You didn't run operation. Check your subtraction. I think you subtracted the wrong way. Same thing. You did the right operation. Works right. Your subtraction, you did the wrong way. 3.4. sign of the bigger. We'll do your subtraction. It's not.
I did keep the friends.
Jenny, that's incorrect. Okay. Operation. This part. Operation. That's subtraction. Okay. Operation. Operation formula. Oh no. All right, let's look at this one real quick. Several folks making the same mistake. All right, what's the operation we're doing? Everybody seems to be doing this part right, which is good. Subtract 3.4 from both sides. That's right. Everybody seems to be doing that part perfect. Great. That gets us x. On the other sides where we got some discrepancies going on. When I'm subtracting this, I've got opposite signs, so I'm going to subtract 3.4 minus 2.7, and then my answer is going to be negative because 3.4 is bigger. Okay, so if you subtract those, 3.4 minus 2.7, you got to borrow 1. That makes that a 2, and that's a 14 minus 7 is 7. 2 minus 2 is 0, and the answer is negative because the 3.4 was bigger. It's not a negative 0, it's a negative 0.7.
Oh.
The 0.7 there makes it a not 0 there. You're right, there is no such thing as negative 0, but the 0.7 makes it different. So be careful of that. When you're subtracting that 2.7 minus 3.4, this is kind of the way that's happening, and then you keep the sign of the bigger one. Be careful of that. But everybody, good job everybody on that step. Getting that operation right. That's the biggest thing there. All right, so let's get fractions out of the way, and we'll be good. So, in order to add or subtract fractions, what do we have to have? Perfect. Good job, mate. Got to have the same denominator. Number on the bottom. Got to be the same. Okay? Are they the same on this one? Great. That's wonderful. But 6 1/3 is a what?
It's a mixed number.
It's a mixed number. Anytime we're going to solve an equation, having a mixed number in there can make it kind of make it more difficult, because if I subtract 2/3, isn't that the operation I would use right here? Are there 2/3 over here to take away from? No, it's only 1/3. So I don't have enough to take away from. So what I need to do anytime there's a mixed number in a problem is convert that mixed number into a what? Improper fraction. And how do we convert a mixed number into an improper fraction? You multiply the denominator times the whole number. 3 times 6 is 18, and then we add the numerator. So that would be 6 times 3 is 18 plus 1 is 19 over 3. And then we do the problem. Okay, so if you see a mixed number in your problem that you get today or tomorrow, convert it into an improper fraction and then do the work. Okay, so subtract 2/3. All said that was the right operation, which that's correct. And now the denominators are the same. So do I do anything with the denominator? No, I just bring it down. Bless you. All right. And then what do I do with the numerator? Do the math. 19 minus 2? 17. 17 over 3. I'm perfectly fine with that answer. Okay. What would it be as a mixed number? 5 2/3. Do not do not, never ever, do not ever convert that into a decimal. Okay, for me. If I'm giving you a quiz or a test or something and I'm asking you to write out the answer, I'm never going to ask you to convert fractions into decimals to present me an answer. I want, if it's a fraction problem at the beginning, the answer ought to be fractions at the end. If it's a decimal problem at the beginning, yeah, decimal answer. That makes sense, right? If it's a fraction problem here, fraction at the end. Okay? That's my kind of class rule there. Let's do one more here. Let's get one that doesn't have the same denominator. So something like n minus 1/2 equals 3/4. What operation should we use? Addition? What are we going to add? Add 1/2 to both sides. All right, good job. That cancels out here. Now, here's the problem. We don't have the same denominator. So we need to find a denominator that 2 and 4 both work with. 4 is the smallest one. Is that the only one? No, but it is the smallest one, and we usually want to work with that least common denominator. So does the 3/4 need to change? No, but the 1/2 needs to. How does the 1/2 change into something over 4? Yeah, to get 4 to be the denominator, we multiply the bottom by 2. If we multiply the bottom by 2, got to do the top by 2. So that's 2/4 that we're adding. So this is the math we're doing here. 3/4 plus 2/4. 3 plus 2 is 5/4. 4. What's it as a mixed number? 1 and 1/4. Again, I will take the improper fraction all day long. That's fine with me, as long as it's reduced all the way. If you had something like 18 over 12, you would need to reduce that because they both could be divided by 2. Okay. If you had something like 20 over 8, you could divide both of those by 4. Those sort of things. But always reduce a fraction if you have one. Fractions should always be in simplest terms, but they don't have to be changed to mixed numbers for me. I like improper fractions actually better because then, because we're going to do something with those answers later on when we start doing like slope and all that stuff. Improper fractions, what you want that. All right. Now, so solving one-step equations, inverse operation, done it with integers, fractions, and decimals, all 3. Pretty good day. It's easy stuff. Okay. Now, on Khan Academy, you go over there. You should see 2 assignments for one-step equations, with some without fractions and decimals, some with fractions and decimals. So get you a Chromebook, get logged in. You're working on that today. Yes, now you can. Yeah. Thanks, Nate. Thanks for being patient with me, bud. It was good. Short, but good.